anymore. In today's maths video, I thought I would do something I've not done on the channel in a very long time, and that is teach you all an area of maths. I had a lot of requests in my first couple videos back since my long hiatus for people requesting me to not only do some math questions and solve them, but actually teach you guys and go over some concepts and areas. And one that I saw a few comments of and thought would be a fun thing to cover was fractions. Which is a crazy area of maths. It's so much fun, but it goes into so many fields, so many areas of maths. It goes so in depth, but we're gonna just cover the basics today. So whether you are new to fractions, whether you know a lot about fractions, or whether you're just here to learn or fall asleep, hopefully this video will be nice and relaxing for you all, and hopefully you enjoy my nice soft whispers, the clicky of the pen on the iPad, or maybe you just enjoy the satisfaction of me solving problems. But anyways, without further ado, if you guys do enjoy tonight's video, be sure to leave it a big thumbs up. Subscribe as well if you're not already subscribed. If you like maths, if you like ASMR, this channel is those two combined, and I hope that you enjoy the kind of stuff you see here if you do. Anyways, without further ado, we are going to get started, and I actually want to grab my little laser pointer for this because I've not used that in a while and I thought it would be quite fun to be. Anyways, without further ado, let's get started. So I thought it would be good to begin by talking a little bit about what is a fraction. Now, fractions come up in life so many times. You might say, you've got half the cake. You might eat half a cake, or you might say it's 12:15. So many instances. You might have $50. You might have, 1/5 of your battery left on your phone, things like this. So they do come up a lot, and it's good to talk about it. So, what is a fraction exactly? Well, the basic way of saying it is that a fraction is a representation of part of a whole. So it is basically part of something entire. So if I have 5 fingers, 1, 2, 3, 4, 5, that is my whole hand. But if I lose my finger, I only have 4 fingers left. I have 4 of my whole hand, 4 of my 5 fingers left. Now, it is usually represented by this. Some people like to write it with a sort of slash like this. I sometimes do that when I'm doing it quick hand, but typically it's drawn like this. Some people also often do it with like curly brackets. It's like a little fancy way like this, but realistically there's no need to do that. But it will have a number on top and a number on the bottom. Now, we're not going to talk about any algebraic fractions today. That's a whole other side of fractions. But let's talk about what these numbers are and what they represent. Now, the number on top in this instance is a 3. This is called the numerator, and it is the top number of the fractions. Numerator, quite easy to remember. It represents how many parts of the whole. Then on the bottom, which in this case is a 4, is called the denominator. Quite numerator on top, denominator on the bottom. A good way to remember it, the D in denominator, D for down, N in numerator for, I guess, I can't think of a word that's the opposite of down. That's up, does not really, I don't know, numerator has a U after it, upper, D, that's how I remember it, denominator. It dominates, it goes in the bigger, it's on the bottom, it's typically the bigger number, so that's a good way of remembering it. Now the bottom number, which is the denominator, is the total equal parts of the whole. Now the best way of visualizing this is with a diagram. So here I've drawn, let's call it a cake. We have a cake with 1, 2, 3, 4, 5, 6, 7, 8 slices or parts in this instance. Now with this cake, how many slices are shaded in? We can simply count it. There are 1, 2, 3, 4 slices shaded in, and there are 4 that aren't. However, there are 8 slices in total, so the total equal parts, they all have to be the same. We can't have any parts bigger than other parts. The total parts is 8, and the many parts that we're looking into is 4. So 4 of the 8 parts are shaded. Now notice that this is also half the cake. If I was to remove all the lines and say to you how much of it is colored in, you would say, well, half the cake is colored in. So coincidentally here, 4/8, nice and easy to see, is just a half, and this is very important for what we're going to go on to next. 4 out of 8 parts are a half. So I hope that's all a good introduction. Let's move on to what we just talked about, where 4/8 is a half, and this comes on to what we call simplifying fractions. So, to simplify a fraction, all we are doing is cancelling it down to its simplest form by dividing the numerator and denominator by the same highest common factor. Now that sounded like a lot there basically. But if we go back up to our example here, 4/8 is much easier than saying a half. You know, that makes a lot more sense. You're like, what is 4/8? So it's just a half. And usually the simpler, pretty much all the time, the simpler fraction, the simpler version of it, has smaller numbers than what it previously did. So you can see the numerator here is a lot smaller than the numerator here, and the denominator here is a lot smaller than the denominator here. You can actually see it's 4 times as small. That's very important for what we're going to do now. Because if we take a look at my example here, 6 divided by 9, or 6/9, we can do something with what is called the highest common factor. Now the highest common factor is simply the biggest number that goes into both these numbers. So with 6 we've obviously got 1, we've got 2, we've got 3, and we also have 6. With 9 we have 1, we have 3, and we have 9. They're all factors of 6 and 9. But what is the highest common factor? Well, it's the highest factor that they both share. So do they both share 6? No. Do they both share 9? No. They both share 3. That's the next highest number. So what we do here is we divide the numerator and the denominator by the same highest common factor. So the highest common factor is 3. We divide 6 by 3. We divide 9 by 3. 6 divided by 3 is 2. 9 divided by 3 is 3. So that gives us 2/3. So 6/9 is 2/3. If I was to draw our pie again, this is going to be a horrible, horrible, horrible diagram, but imagine I split this up. That is not ninths at all. How do you split into thirds? I guess I want to split thirds into 3, don't I? So I'm going to go like this. Really, this is not to scale, not perfect at all. But if we had 9 parts, and I shaded in, for example, let's say 1, 2, 3, 4, 5, 6, round to here. Yeah, this is a really bad drawing, I'm very sorry, but you gotta just accept it. You can see 6 of the 9 parts are shaded in, but if we go back to my original drawing, this is just 2/3 of it all. 1, 2, 3, 1/3, 1, 2, 3, another third, and 1, 2, 3, the other third that's not shaded in. Okay, I'm gonna get rid of that. It's pretty horrible diagram, to be honest. So with that, let's do a couple examples, and I'll keep the definition up so you guys can kind of follow along as we go. So the first one we have here is simplify 18/30ths. Wow, that's some big numbers there. Well, once again, we have to look for the highest common factor. So let's write them out, shall we? Let's do it with 18 and 30. Now we'll start with 1, of course. 18 we have 2. Then we have 3 goes into it 6 times. 4 doesn't, 5 doesn't, 6 does, 7 doesn't, 8 doesn't, 9 does. And I think 9 is the biggest number other than 18. Next, with 30, we have, what do we have? 1, 2, 3, 5. Once again, you can see 1 goes in 30 times, 2 goes in. They all have opposite ones, so 1 will be 30, of course. 2 will be times 15, so 15 goes into it. 3 goes in 10 times. And I believe that is it. Oh no, we have 6 as well. 6 goes into it 5 times, so 10 times 3, 5 times 6. So what is the highest common factor here? Well, it's not 30 or 18, 15, 9, 10, no, 6. 6 is the biggest number, so we know we're going to be dividing them both by 6. So we're going to have 18 divided by 6, and 30 divided by 6. And this gives us 30 divided by 6 is 5. 18 divided by 6 is 3. So 18/30ths is the same as 3/5. I'm so sorry about my earphones hitting off the table. For some reason I might try and move it a bit closer so it doesn't do it. Okay, let's move on to the next example. We have simplify 25/100ths. Now this is quite an easy one actually, because we have a little trick for this time. If we have 100, all we have to do is look at the top number and see how many times it goes into 100. We can always do this. If it doesn't go in a certain amount of times, it cannot be simplified. For example, if we had 33/100ths, although people normally call this a third, 33 doesn't go into 100 an exact amount of times. It goes roughly 3. But if we have something like 50, we know 50 goes into it twice. It's a half, basically. 25 goes into it 4 times. If this is the case, it's very simple. We just want to write 1 on the top, and however many times on the bottom that it goes in. So it'll be 4, so it's just 1/4. If the number is bigger than 50 though, that's where you need to start doing your highest common factor trick. Okay, let's move on to something called mixed numbers and first. A mixed number. What is a mixed number? It is a combination of a whole number and a fraction. So we can see here in the example, we have 2 pies, both of them. I've gone from cake to pie now, apparently. The first pie is cut into 3 slices, all of which are shaded in. And the second pie has 1 slice shaded in. With this second pie, we'd represent that as a third. We know that. If the whole pie is shaded in, well, that's a whole. It's just 1. Note that 1 is the same as saying, 1 over 1. But also it's the same as saying 2 over 2. It's the same as 3 over 3. 3 over 3. 4 over 4. And the reason being is, well, when you simplify these, like we did before, divide the top and the bottom by the same number, basically. 4 divided by 4 is 1. It always goes down to 1 over 1, which is just 1. So here, a whole pie is simply going to represent 1. So you would say in this example, we have 1 and 1/3, or you could write that as 1 add 1/3, because you have both of them. Or we could also say that this is 3 over 3 plus 1 over 3. Very interesting for what we're going to go on to doing next. Whereas an improper fraction is a fraction where the numerator is greater. Very important that the numerator has to be greater than the denominator. So before we looked at examples where the top number is always smaller than the the bottom number is bigger than the top number, or the top number is smaller than the bottom number. Gosh, I don't know why I struggled there. But with an improper fraction, the top number, 4 over 3, is bigger than the smaller number. Oh my gosh, I can't speak. The top number is bigger than the bottom number. Numerator bigger than denominator. There we go. I said it. So from our example up here, 1 and 1/3 is the same as 4/3. We have 1, 2, 3, 4/3. Now note that that's not the same as 4/6, even though we have 1, 2, 3, 4, 5, 6 wholes, or 6 parts in total. That does not mean you write 4 over 6, because 4 over 6 is 2/3, isn't it? So you would count the amount of parts, 4, and keep it as whatever they're divided by, which is 3 4/3. And that gives you 1 and 1/3. What you're essentially doing here is adding the top parts and multiplying the bottom parts. So you take the bottom, this one here, multiply by the bottom, 1 times 3, and add whatever is on the top. So plus 1, so 3 times 1 is 3, plus 1 is 4, and then you keep 3 on the bottom. Okay, so with that, let's do a couple more examples, and we'll go over these nice and slowly so you can understand. Now, one thing I want to mention is, in some examples going forward, I may refer to an improper fraction as a top-heavy fraction. I was just taught this. I know they're technically called improper, but sometimes we refer to them as top-heavy. It just means the top of the fraction is heavier than the bottom. There's more of it than there is on the bottom. Numerator is bigger than the denominator. So convert 5 and 2/3 to a top-heavy fraction. Okay, so this looks quite complicated at first, but let's use this method that we used down here. We multiply by the bottom, so 5 times 3, and we add whatever is on the top, 2, and we divide by whatever was on the bottom before, so 3. Now I'll show you the reason why we do this this in a second after we work out the answer. So 5 times 3, remember bid mass, you do multiplication before adding. So 5 times 3 is 15, plus 2 is 17, divided by 3, like so. Now, when doing exams or questions, it is fine generally to leave your fraction as a top-heavy fraction if you're just doing other kind of fractional work. Some people like to convert it to a proper fraction, with a mixed fraction like so. But in this question specifically, they've said leave it as a top-heavy fraction. Always check though when you give your answer, can it be simplified? Because although saying something like 4/8 as your answer is fine, a lot of exam boards and teachers and markers prefer you to simplify as far as you can. Sometimes it'll actually say, convert and simplify. Here we cannot simplify this any further because there is no common or highest. There's no common factor between 17 and 3. 17 is a prime number. So, alrighty. Now we move on to why we do this before the second question, because I want to quickly cover that. So why do we multiply this by the bottom number and add the top number? Well, if you think about it, if we have 5 and 2/3, we have 5 pies that are split into 3. Remember back up here, this is 1 pie split into 3, which is why there's a 1. So if we have 5 pies split into 3, we have 5 of these things. So imagine 5 of them in a row, and you counted them all. 1, 2, 3, plus 1, 2, 3. It's always going to be times, or plus another 3. So 5 of those 3s is just 5 times 3. So that's why we multiply it by the 3. And then we just add the 2, because that's what's left over. So I hope that makes sense. So what does the second one say? Convert 22/5 to a mixed fraction. Here we're doing the opposite. The best way to do this way, or this type of question, is see how many times does the bottom go into the top. It goes in, well, we have 5, 10, 15, 20, 4 times, because the next one would be 25. We can't do that, it's into 23, so we have 4 whole pies that are going to go in there. And what's left over? Well, there's 3 left over. So we'd have 3/5 remaining. And you can check this. You can actually, the good thing about this is check your answer. Will this work if you convert it back to a top heavy? Let's do it in blue to the side. 4 times 5 plus 3 divided by 5. This technically means divided by, but it's a fraction. 4 times 5 is 20, plus 3 is 23 over 5. And that matches. So you know that you've done it right. That's the great part about this. Okay, using what we've learned so far, we're going to go into some fun stuff. Starting with adding and subtracting fractions. So this is where we take one fraction and we take another fraction and we ask, what are they together? So if I have half a pie, what is that pie plus, let's say, 3/4 of a pie? Now for adding and subtracting fractions, it's very important if the denominator is the same. Very, very important. If the denominator is the same, we can add or subtract 2 fractions by adding or subtracting the numerators. So in this example I've written, we have 15/13, so this is a improper fraction, top heavy, plus 8/13. These two we can add together nice and easily by adding the numerators because the denominator is the same. 13 is the same on both. So all we do is add 15 plus 8, which is 23. 13 stays on the bottom. We do never add or subtract the denominators. And then if you'd like, you can convert that to 1 and 10/13 because 13 goes into 23 once. And there'll be 10 left over. Okay. Another example here. 5/6 minus 1/6. We have 6 on the bottom of both, so it stays the same. And then on the top, 5 subtract 1 is 4. Now this can get simplified. Remember I said always make sure you can simplify your final answer. 4/6. How do we simplify that? Well, let's grab our blue pen. Highest common factor. Sometimes it's quite easy to just see it, visualize it. You can kind of tell it's not going to be 4. It's not going to be 6. It's not going to be 3. It looks like it's 2. And you can, the good thing is about it is if you get the wrong number, just check what your answer is and can that be simplified again. If I had picked something different and I'd got my answer down to be 4/6, thinking that was it further simplified, it can get simplified further because I can see, oh, I can now divide it by 2. 4 divided by 2 is 2. 6 divided by 2 is 3. However, here's the big caveat. If we don't have the same denominator, so if we don't have 13 and we don't have 6 on the both, we must convert the fractions to have a common denominator. This just means they have the same number on the bottom. And to do this, we find the least common multiple of the denominators. Now this is similar but somewhat different to the highest common factor. The highest common factor, remember, is the highest factor of them both, whereas the least common multiple is the lowest number that goes into them both. It's the easiest way to do it. So, in this example here, in this example here, we have 5/6 minus 2/9. Here 6 is not the same as 9, they are different on the bottom. So we take a look at the multiples, or the factors. And the multiples of 6, we have 6, 12, 18, 24. I always rule out 1 because it's never going to be 1. And then, or the multiples of 6, sorry. I'm talking about the wrong thing. The multiples of 6, we have 6, 12, 18, and 24, and so on. The multiples of 9 are 9, 18, 27, and so on, 36, 45, 54. Then we look at the lowest number that they both share. So the multiples of 6, the lowest number that 9 also has is 18. So our lowest common denominator is going to be 18. If you need to learn that or run that back, feel free to do so. So here we put 18 on the bottom. Now how did I get these numbers 15 and 4 on top? Is it not supposed to be 5 and 2? Well, this is the important bit right here. Whatever we do to the old denominator of each fraction, we also do to the old numerator. So how did I go from 6 to 18? I multiplied it by 3, right? So to go from 5 to the new number, I also multiply it by 3. 5 times 3 is 15. Same here, 9, I multiplied it by 2. So 2, I must multiply it by 2 to get 4. And only now, because we have the same number on the bottom, I can subtract them. 15 minus 4 is 11. 11/18, which you cannot get So with that, let's do a couple examples, and hopefully you can follow along. For the first one, we have a nice easy one. Find 5/7 plus 3/7 and 5/7 minus 3/7. Let's start with the first one. We have 5. Now I like to sometimes write minus 3 over 7, but you can quickly see, oh sorry, this is plus 3, the first one. Now this is going to just be 8/7. Now I'm going to be lazy and I'm going to leave it as an improper fraction. I'll let you figure out what it would be if it was a mixed fraction. Let me know in the comments, what is this as a mixed fraction? Now the second one, we're going to have 5 minus 3 because 7 is the same on the bottom of both fractions. That's fine, we don't need to find a common denominator here. And this is equal to 2/7. Nice and easy. The second one, however, find 2/3 plus 1/5. We don't have the same denominator, so we must find a common denominator. The lowest multiple that they both share. Let's write this out to the side again. What are the multiples of 3? We have 3, 6, 9, 12, 15, 18, and so on. And then 5, we have 5, 10, 15, can you see any yet? 20, 25, so on. What's the lowest number in these two columns where they're two rows where they're the same? Do you want the answer? If you said 15, well done. 15 is the lowest number that both rows have that are the same. So we convert it to be over 15 plus over 15. Now, what did we do to the 3 to get 15? We multiply it by 5. So 2 times 5 is 10. What do we multiply the 5 by to get 15? We multiply it by 3. Sometimes it's the opposite. It usually is. If you cannot find the lowest common denominator, the best thing to do is just multiply both bottom numbers. 3 times 5 is 15. That's most likely what it's going to be. You can see in my example up here, 6 and 9, they're not the same. 6 times 9 is 54. You could put it 54 and you would see that 18 goes into 54, so you'd eventually get down to 18 when dividing by 3. But in some cases you can just multiply them both. Then we multiply this by 3, so then we're left with 13/15, which cannot simplify. So that is our final answer. Now we've looked at adding and subtracting fractions. Now we're going to do something a bit fun, and we're going to look at multiplying and dividing fractions. Now multiplying fractions is actually really, really easy. We don't need to worry about any common denominators or any high common factors or anything like that. All we have to do to multiply two fractions is multiply the numerators and the denominators. It's as simple as that. So in my example, 2/5 multiplied by 3/7. We multiply the two numerators on the top of the new fraction, 2 times 3. And we multiply the two denominators, 5 and 7, 5 times 7. And we put a multiplication, obviously. And then in our answer, 2 times 3 is 6. 5 times 7 is 35. There's our final answer, and it is simplified as much as it can. But this is very important. We cannot use mixed numbers if we want to multiply. We must first convert to a top-heavy fraction. Okay, so for this example, we have evaluate 5/12 multiplied by the mixed number 2 wholes plus 2 ninths. Now for this one, must do what we said here. We must convert to a top-heavy fraction first with the second part of this. So first, starting off with 5/12, that can stay the same. But for the second one, we're going to have to convert 2 and 2/9. Now, hopefully you can get there before me. Let's see if you can. What's 2 and 2/9? As well, it's going to be a top-heavy fraction or an improper fraction. So 18 plus 2, we're going to have 20 over 9. Did you get there before me? Once again, 2 times 9 plus 2. Now this, gosh yikes, we're getting into some bigger numbers here. This isn't great. But we have a little trick we can do, and I'll show you that in a sec. Let's work out what it would be though. So 5 times 20, that is 100. And 12 times 9 is 108. Now we need to simplify that. That's not nice. I will tell you, however, it is 25 over 27. They both have 4 that goes into them. So 525 goes into 104 times 27 goes into 108 4 times. But would you believe me if I told you there's a faster way to do this? Let me show you. Let me actually just erase everything we just did. Let's get rid of that. I'm going to delete the multiplication as well. I'm going to move the multiplication up here and down here because it's the same, that's what we're doing, right? But instead, I'm going to grab this pen. I'm going to take this 5 and I'm going to draw an arrow down to the 9. And I'm going to take this 12 and I'm going to draw an arrow up to the 20. Here we are going to do what's called cross multiplication. Let me write it down. It's called cross multiplication. It gets the name because, of course, you're making a cross. Now what you do here is you compare these two numbers, 5 and 9, and 12 and 20, and you look if these pairs have a common factor. If so, what is the highest common factor? We talked about that earlier. 5 and 9 don't have any common factors, 1, 2, 3, 4, 5, none of them. But 12 and 20 we do. We have 2, but we also have a higher number. We have 4. In other words, 12 is divisible by 4, and so is 20. We can take this cross multiplication and rewrite our new multiplication fraction. So the 5 and 9 are going to stay the same because we couldn't do anything with them. But 12 divided by 4 is 3, and 20 divided by 4 is 5. Now you can only do this trick if the cross numbers are able to be reduced. If you can't do it for either, you must do it as we just did it before. This here makes this so much easier. We're not working with the hundreds and 12s and 9s. We got 25, or 5 times 5, which is 25. And we have 3 times 9, which is 27. Really easy. We didn't need to simplify it. And that's because we did the simplifying in this stage. And that is cross multiplication. Okay. Let's take a look at what we do when we divide fractions now. This one is quite sneaky. To divide fractions, we flip the second fraction. I'll show you what flipping means. And we change the divide symbol to a multiply. Now that seems really, really weird. A lot of the time when you learn this method, I was told this anyway, you just kind of have to accept it. I I was never explained why. I was just told that that's the rule when dividing fractions. I obviously know why now, and that's because it's called using the reciprocal. So, if we had, let's say, 3/4 divided by 2/5, we keep the first fraction the same, and we flip the second fraction. So instead of 2/5, we now have 5 divided by 2. It looks really weird. And instead of a divide, we have a multiply. Almost seems counterintuitive. But working this through from what we just learned, so we can't do any cross multiplication here. So we have 15/8, or 1 7/8. Now why do we do this? Well, we use the reciprocal because saying 3/4 of 2/5 is saying how many times does 3/4 go into 2/5. That's basically saying 3/4 times 5/2, because you're doing 3/4 divided by 2/5. So with that, let's do an example. Evaluate 2 3/8 divided by 5/16. So we're going to convert to a top-heavy fraction at the start. We're going to do this relatively quickly, so hopefully you can keep up. We have 16 plus 3 is 19/8 divided by 5/16, which we're going to do converting to be 19/8 times 16/5. And I'm going to pause here. Can you see our little trick that we can do? If you can spot it, I want you to try and work out what number do we use and with which pair or pairs. The answer is we can only do it with the 8 and 16 pair. And our number is 8. 8 goes into 8 and it also goes into 16. So we divide them both by 8, which is going to give 19/1 multiplied by 2/5, which is going to give 38/5. Or we can convert that to, what's it going to be, 6, 7, oh, I did not mean to use that number there, 7 3/5. Should be the right answer. Hopefully I've not messed that up. Anyway, with all that we have learned so far, I hope you guys have enjoyed learning about these fractions. I thought it would be time to go on to some practice questions. Now, I am going to work through these myself. If you would like to do them yourself, feel free to pause, take a look at the questions now, screenshot them, whatever, work them out on your own. Let me know in the comments your answers. There's some fun ones down here towards the end. There's 10 questions in total. If you can work them all out, I hope you enjoyed. But I'm just going to sit here, talk through my working, and work them out. So, let's get started, and I hope you enjoy. Simplify 12/18. Okay, so what is our highest common factor here? So we have 6 and 12, so it's 6 probably. Okay, so let's assume it's 6. 6 goes into 12 2 times, and into 18 3 times. So that is going to be our final answer. Let's do a check though. 2/3 multiplied by 4, so I have to do the same to the top. And to the bottom of this one, we multiply by 2 to get 8, so we get 6. And then we're going to get 10 eighths. Or we can just divide by 2 to get 5 quarters, or 1 and 1 quarter. But we didn't need to do that. We could have used 4 as the denominator anyway, but for a bit of fun there, like we talked about earlier. Next, find 5/6 minus a quarter. Okay. Common denominator of 6 and 4. 6, oh, it's 12. Okay, that was pretty quick to work out. So 12, what do we do to the 6? We multiply by 2, so 5 times 2 is 10. And we're subtracting, it's going to be over 12. We multiply by 3, so 1 times 3 is 3. 10 minus 3 is 7. 12, so now can it be simplified? Nope. Question 5, evaluate 7 thirds, multiply by 2 bits, cross multiplication first, 3 and 2, no. 7 and 5, no, so we have to do it the long way. 7 times 2 is 14, and 3 times 5 is 15. Oh nice, 14 15ths, that's kinda cool. Okay, question 6. 4 ninths divided by 2 thirds. Okay, so let's do our flip method. Let's do it all in one step. Add the multiply, flip that 3 over 2. Can we do cross multiplication? We can. So let's write this as a new set of fractions. The first pairing, 9 and 3. That's obviously going to be 3. So 9 divided by 3 is 3. 3 divided by 3 is 1. 4 and 2 is 2, so 4 divided by 2 is 2, 2 divided by 2 is 1. We're literally just multiplying 2 thirds by 1, so that's just going to be 2 thirds. Question 7. Find 9 fourths quarters plus 5/6. We need a common denominator. Okay, so what's that gonna be? See, it's 12 again, okay? They love 12 in these questions. 12 multiplied by 3, so that's gonna be 20. 7 multiplied by 2, so that's 10. That gives us 37 twelfths. Hopefully I've not made any mistakes, or that's just 3. And was that 1/12? Cool. Now if that could simplify, we would have known we made a mistake. Okay, question 8. Evaluate 7 and 5/6 minus 8 ninths of 2 and 3/4. Okay, so in maths, of means multiply, so we do bit mass, we do this first. 8 ninths of 2 and 3/4. We start with this part. Okay, so let's convert to a top-heavy fraction. So 8 ninths of 2 and 3/4 is 11. So 2 times 8 is 2 times 4 is 8 plus 3 is 11 over 4. Now we can cross multiply this. 8 and 4 are going to change, so divided by 4 on both, we get 2 and 1, and then 11 and 9 are unfortunately staying the same, so we're going to get 22 over 9. Okay, we'll just keep that as it is. Second part of this question, 7 and 5/6. Let's convert. 7 times 6 is 42, plus 5 is 47. Yep, 6. And we are subtracting 22 ninths. Gosh, that is not nice at all. Wow. That's not nice at all. Okay, we need to multiply 47 by 3. Which is going to give us 141 18ths. Okay, sure. Minus, this can be over 18 as well. 22 times 2 is 44. Oh, this is going to get a little bit nicer, I guess. So we subtract them. We are going to get 97 over 18. Again, not a very nice number, but does 18 go into 97 by any chance? Let's have a look. Let's do it down here. 18, 36, 54. Then it'll be 72, right? Yep. And then it'll go into 90. No, so it goes 1, 2, 3, 4, 5. Remainder 7 18ths. Okay, that was not a nice question at all, but I will take it. Evaluate 5/6 minus half divided by 1 3/4. Okay, so we have brackets this time, so we're gonna do that first. In bit mass. So 5/6 minus a half. I'm gonna be sneaky. I'm gonna do this in my head. I know a half in terms of 6 is 3/6. So 5/6 minus 3/6 is 2/6. And then I'm gonna simplify that in my head again. 2/6 is 1/3. So that equals 1/3 divided by, and then this is gonna be 7/4, which is the same as 1/3 multiplied by 4 over 7. And we can't do any cross multiplication, so we're gonna have 4/21ths. Cool. And then question 10, I love this question. A half plus a third plus a quarter plus a fifth. So we need a common denominator of 2, 3, 4, and 5. Let's see. 5, no. 10, no. 15, no. 20, no. 25. Oh no. What is this gonna be? I tell you what, let's multiply them all together. 5 times 4 is just 5 factorial. 5 times 4 is 20 times 3 is 60 times 2 is 120. There might be a better one, but I'm going for 120 plus. Let's just copy and paste that. Plus over 120 over 120 is going to be 4 times 3 over 120 is our common denominator. I hope you guys enjoyed this, just like nice close-up whispering as I solve some problems. So multiplying to get 120, I multiply that by 60. This one here I multiply by 40. I multiply by this 30, and I multiply this by, I'm being stupid, what goes into 25, no, my brain is blanking, 24, there we go, 24. Okay, now we add all those together. 60, 100, 130, 154, 120ths. Now that can surely simplify. I would leave it like that if I was being lazy, but I'm not going to be lazy, so let's simplify it. I mean, it's going to be 1 and how many 120ths? 34 120ths, right? do it by 2 for sure. That's going to give 17 over 60. Can that do anything further? No, I can't, can it? So our final answer is going to be 1 and 17/60ths. Oh my gosh. Well, there we go, everyone. I have just solved all our questions, and that finishes up today's video on teaching you everything there is to know about the basics of fractions, from multiplying, dividing, adding and subtracting, common denominators, simplifying, mixed numbers and improper fractions, top heavy, and everything else you need to know. So with that, I really hope that you all did enjoy today's video. If you did, be sure to let me know by leaving it a big thumbs up. I hope you like this nice long video as well, and let me know if you would like to see another teaching you an area of maths video, and if so, what area would you like to see? Anyways, thank you all for watching. I have a very exciting video coming next week, so be sure to subscribe and turn on notifications to not miss it. It's a very, very fun one, and I cannot wait to share it with you all. Anyways, hope you found this nice and relaxing, and I'll see you all in the next video. Good night, everybody.